Hi, boys and girls, and welcome to Chapter 4. We're going to be learning about multiplying decimals. We've already added and subtracted decimals. Now we're moving into multiplying decimals, and then after that, we're going to talk about dividing decimals. Now, in this lesson, we will definitely be looking for patterns and connections between numbers, and we will always attend to a precision that's extremely important in math. What is our goal? Our goal is to use patterns to place the decimal point when multiplying decimals. And our goal is to be right here, a level 3, which means I can use a pattern to place the decimal point when I am multiplying decimals. Now, what's important is that you understand what you already need to know how to do in order to begin this lesson. I must be able to multiply powers of 10, which means I need to understand that maybe 10 to the second power is 100. So if I had 10 to the second power times 2, I need to know that that is 200. I also need to know strategies for basic multiplication, which means, hey, I need to know that 6 times 8 is 48. I need to know my math facts. So, what is the difference between adding and subtracting decimals and multiplying decimals? Let's take a look at that. Stephen scored 54.5 points in the first game of Tinkerwa and 48.99 points in the second game. How many more points? Here's a question. How many more points did he score in the first game than in the second? And then how many points did he score in the games combined? So there are two things this question is asking me to do. And I'm going to circle the number and the units so I can compare. Okay, I'm looking at points. I'm going to circle the number and the units so that I know what I'm looking at. We don't want to compare apples to oranges. What we're looking for is the number of points they scored combined and the number of points they scored, or how many more points Stephen scored than in the first game than in the second. So how many more is a key word. All right, so let's set up our equations. 54.5 minus 48.99. And I'm going to put a placeholder here to make it easier for me to subtract. Then I have 54.5 plus 48.99, and I'm going to put a placeholder there again as well. I'm going to need to regroup, so I'm going to take a tenth and move it over to the hundredths. So I'll have 10 hundredths. 10 minus 9 is 1. Now I cannot subtract 9 from 4, so I'm going to regroup my hundredths from the ones. 14 minus 9 is 5. I need to regroup yet again because I cannot subtract 8 from 3. So I'm going to regroup to the tens and I'm going to subtract. Now I have 13. I hope you can see it there. 13 minus 8 is 5. Now, to help myself, I can place a placeholder there just so that I can see a little more clearly. This is the number 5 and 51 hundredths. So we could say Stephen, we'll abbreviate his name as an S. Stephen scored 5 and 51 hundredths more points in the first game than in the second game. Okay, now we have 54.5 plus 48.99, or we could say 48 and 99 hundredths, or we could say 54 and 5 tenths. Nonetheless, I need to add these two numbers together because I'm looking for their score or his score combined with the two games. So let's add. I need to regroup here. I need to regroup here again. So we would say Stephen, we'll abbreviate his name S, scored a total, let's use math vocabulary, scored a total of 103 and 49/100 points. We don't really say that in real life. In real life, we would say Stephen scored a total of 103.49 points. Okay? Now let's look at multiplying decimals. Now we have a different situation. Nathan decided to build a Lego model of Cornerstone Charter Academy Elementary School. The ES stands for elementary school. If the height of the building is 45 feet and the model is 1/100th of the actual building, what is the height of the model? Well, we have 45 feet times 1/100th. I'm going to move my decimal point because we're talking about 1/100th. There are 2 zeros in the hundredth. So I'm going to move my decimal point twice to the left. And what do I end up with? 0.45 feet. It's the same thing as saying 45 times 1/100th. You need to understand how this looks in both forms. 1/100th written as a fraction and 1/100th written as a decimal. They are the same thing. So we would answer the question, the height of Nathan's model is 0.45 or 45/100ths. If you're not sure how we did that, you can rewind the video and watch again. But let's move forward. So here we have the opportunity to place the decimal. Now this might be intimidating to you, but keep in mind, we recognize these exponents from chapter 1. None of our math goes away, it just kind of builds on itself. So let's take a look here. 10 to the 0 power is the same thing as 1 times 5 and 26/100ths. So of course, the number stays the same. Now we have 10 to the first power times 5 and 26/100ths. We're going to move the decimal. I'll switch colors to make it easier for you to see. Once to the right. So now we have 52.6. Now we're going to move the decimal twice to the right because of the 2 exponents. We have 526. Move the decimal 3 times. Now we have 5260. And then we're going to count back 3 spaces. 1, 2, 3. And place our comma to show the number 5,260. Boys and girls, when you have to move the decimal point 4 times, place the digits there so that you can see them. That's a good strategy to make sure that you have enough digits in your number. Then count backwards and place the comma. Now we have, oh, I put too many zeros. We would have had 526,000, but I realized I made a mistake there. There should only be 2 zeros because we moved the decimal point 1, 2, 3, 4 times. And now for the 5th time, 1, 2, 3, 4, 5, place the zeros. I'm going to write all of my digits. Then I'm going to count from the right, 1, 2, 3, and place the comma. Pause the video and try the other side. If you remember correctly, 5.26 times 1, easy peasy, 5.26 or 5 and 26/100ths. Now I have 5.26 times, this decimal point actually represents the fraction as well, 1/10. So I will move my decimal point once to the right, which is 0.526 or 526 thousandths. And I'm going to move my decimal point twice this time. And here is my new number. And then I'm going to move the decimal point 3 times. And I have, this would be the tenths, hundredths, thousandths, 10,000, 100,000. So I have 526 hundred thousandths. Oh, say that 3 times fast. Geez Louise. Let's look at this algebraically written. We're trying to figure out the value of n. So what do we need to do? Well, what we're asking is, what number times 10 to the third power would equal 456? Well, all I need to do is look at the 3 and move the decimal point 3 times to the left. Why am I moving the decimal point to the left? Because I'm saying there's some number that when I move the decimal point 3 times to the right will equal 456. Well, to figure that out, I have to do the inverse. So the inverse would be to move the decimal 3 times to the left, so that I would say, oh, I have 456 thousandths. Keep in mind, I moved the decimal point 3 times to the left this time because I'm saying 10 to the third power times some number will give me 456. What would give me 456? 0.456 times 10 to the third power would equal 456. Now I'm going to check my work. Is it true that 4 or 10 to the third power times 0.456 would equal 456? Let's see if that's true. 1, 2, 3. Yes, it is true. So my answer is correct. Now I'd like for you to try some problems on your own, pause the video, and then come back for the answers. Okay, boys and girls, here are the answers. I hope that you got them correct, and I hope what you're noticing is what the point of this entire lesson is. The point is to recognize patterns in the numbers. Notice how we moved the decimal point. And for those of you who may not have gotten it correct, use this strategy. Go ahead and place a decimal point in zeros if you'd like to after the numbers. That way it might be a little bit easier for you to recognize where the decimal point is in a whole number. Check your scale, see where you are. If your practice problems were correct and you can give written proof and verbal proof, then you are a 3. And that's exactly where we want you to be. If not, note where you are on your scale so that you can get the assistance that you need. Thanks for watching.